I'm sorry. So we have last speaker now. We have Professor Vinod Gupta. He's from Space Design Consultants. He's also a technical member of the Reha committee. In fact, we have only one Reha compliant building on campus. We hopefully would have more to go in the days to come. He has his presentation on thermal control in vernacular architecture.
I grew up in Old Delhi and in a traditional house which was naturally cooled, and all houses used to be like that. It was not a very special house. So some of the experiences that I have of these old houses have been put together, and an interpretation of how we lived in these houses or in these buildings. So one of the questions that was asked very often in the morning is, how did these people, in the old times, how did they manage to do things so beautifully and so well? And I think the underlying assumption is that we are smarter today, and that is why we can do things. But these people didn't really know, and that is why we are surprised that they could achieve the things that they did. And to me, this is actually something which one needs to address in a seminar like this, because everything that was done earlier, the people were as smart or even smarter than what we are today, and the buildings were better, they were more sustainable, they have stayed all this time, and we can't do it. So we have only ourselves to blame, and not that the fact that we have achieved something great. This is the effect of science and technology that is with us. We always believe that science has progressed a great deal, and therefore we as human beings have also progressed. But anyway, I come to thermal control here, and when we come to an old building, we are always surprised by how cool it is and how nice it is. And there are three things that made this possible. One was the urban design of it, which Katie has talked about at great length. Then there was the building design itself, and thirdly, it was a question of how people use these buildings. And all three put together made it possible for us to be comfortable in these old buildings. About 40 years back, I started working with this idea of passive solar construction, and that's when I started teaching at SPA. And I took up this research project of looking at some of the old buildings, and of then going on to construct some experimental buildings. And one of the cities studied was Jaisalmer, and this is one may not believe it, but we didn't really look at just the architecture of it or the quality of buildings. We also actually measured temperatures in those buildings and in the city. Today, when we talk about cities, we are always told, the cities are urban heat islands, and every data that we have will show that the temperature inside the city is so many degrees higher than what it would be outside. So to prove or disprove this, we actually went into Jaisalmer and we measured temperatures on the street, and we went out of the city into we had a meteorological station outside the city that was giving us temperatures. And then we also had the traditional open areas, rural areas outside the city, and we measured those temperatures there just to compare whether what is a better thing that we have. These streets were laid out in the correct direction as far as preventing hot air from getting through them were concerned. The buildings all shaded each other, as Katie had already pointed out. On the right, we have a section of the city. This is a part of the city here, which is actually the major part of Jaisalmer, where all the Havelis, beautiful Havelis, are located. We didn't look at the fort, for instance, which is very special, but it is not where the common people lived. That is the area which we have expanded, and all the houses were tied together. They were all courtyard houses. And the temperatures that we measured in the streets were actually at 4 different places, and the first 3 curves actually depict for 3 different places in the city of Jaisalmer, and the 4th one is outside and in a rural area. So we found that in the summer the temperatures in the streets were 3 degrees or so lower than the meteorological station temperatures, and this was consistent in the day, and at night they were 3-4 degrees warmer than the meteorological station. The meteorological station here is depicted by the solid curve, and the street temperatures are by the dotted curve. So this was something which was measured a long time back, and there was no urban heat island effect at all. And then we measured these same temperatures in the winter months, and we found that the streets were nearly as warm during the daytime. So this cooling effect of the streets was there only in summer and not so in winter. But in winter the temperatures in Jaisalmer fell to about 6 degrees, 8 degrees, and the streets were much warmer than the outside. So we had actually a very nice effect that was built in, which was that the streets were warmer in winter and they were cooler in summer. So when we come to buildings, there are these 7 rules that Katie had given. I have 7 rules for the buildings, and there was, first thing is the thermal mass, how much thermal mass we put into the building, and how we control the openings, how we shade the buildings from the sun. Then they had a great technique which was making the building envelope, the outside of the building, respond to different conditions that were there. They controlled the ventilation through the buildings in various ways, and they used the cooling of the spaces at night. And I think finally they had the way of using buildings which was flexible. So there was no rigid rule that had to be applied to this. The effect of thermal mass is something which is the best example is from the pyramid of Giza. They have this Queen's chamber and the King's chamber in it, and they are connected by ventilation shafts to the outside. And the thermal mass is so great that the temperature inside these chambers remains at the average temperature, which I think is, I don't have the number, but I think it is 23 degrees all through the year. And one theory is that this was actually the place where they put their the proportion of pi, which was very important to them that time, and they had created this in that proportion. And because this was completely constant all through the year, this proportion would stay with them as a physical measure. We know all about the Taj Mahal, how cool it is, and I think the concept of when we look at temperatures today in a building like this, and the air conditioning industry and the association of heating and ventilation engineer, ASHRAE as it is called, they define for us the temperatures that we should have, and they all deal with 2 things. One is air temperature and the other is humidity. They don't really deal with the concept of air movement very much, because we don't have fans here. So the air movement is lost. But I think above all, what these buildings depended upon was something called the radiant temperature, which we actually don't even have instruments to measure directly. But our body senses this radiant temperature. Radiant temperature is the temperature that all the surroundings have, and we absorb the radiation from all of these places, and we are able to feel this. So when you step out in the sun, the air temperature, you can be in the shade outside, and when you step out of the shade into the sun, what changes is the radiant temperature, because suddenly you have a source which is 7,000 degrees, and otherwise you were away from this, and the air temperature remains the same. So but this is the kind of thing that changes, and these buildings, all our traditional buildings, were actually able to control the radiant temperature without having too much of control over the air temperature inside them. The other example which this is also another example of controlling thermal mass and controlling the radiant temperature inside. This is from Jaisalmer, and I have here the plans of this building. The black actually is the open space in the plan above. It's a courtyard. It's a very old drawing, and the most of these, there are. If we look at this plan, this is the main house. There is a big open space courtyard, which is actually a very different proportion of a courtyard, because this is low and this is a tall courtyard space here. And then this here were actually air ducts, ventilation shafts, which were an important part of the way in which the building responded to the outside. It was small amounts of air movement. The fact that you had different size, 3 different sizes of courtyards. One was this, very tiny. This was wider, as wide as this. This proportion would have been only this much, and then you had a very wide one here. So the way solar radiation was received by this, the temperatures in these spaces changed, and the spaces which were connecting these were actually the best spaces, because this is where air moved, and ever so slightly through this. And this movement of air was controlled because it was always from the the warm air going out and cooler air coming in. If you have a situation where the outside air was warm and the inside air was cool, no air movement would take place. So this is how we used to live in the houses in old Delhi without a fan. And when I went to Jaisalmer, that was in 1980, I think, or 78, they still were not using electric fans at all. I don't know if they do now. A similar kind of building with, it was not just air movement, it was also dust control in a dusty place like Jaisalmer, which was important to them. And the effect of this kind of slow air movement through the building was that the dust was already settled out, and it was not a blowing wind that went through the buildings. They of course had some urban design ways of controlling the dust, and that is by building the wall around the city, which was quite high. Then they, the beautiful decorations on these buildings, which we admire on the buildings in Jaisalmer, these were not jalis, these were actually just surface perforations, and they were not through and through. And we checked whether, what is the effect of this on the thermal environment. And we found that these actually cooled down the surface. They received the same amount of sun, but they shed off the sun and they were closer to the air temperatures. So these jalis actually, they are not jalis, they are solid walls, but perforated, and they always had a temperature which was lower by a few degrees from the surrounding plane surfaces. Then there was a question of, the windows. They didn't have glass, but they used windows of very many different kinds. I have 2 examples from Amer Fort here, and the privacy was something which was ensured. On the left, we have actually a window which is no wider than an inch in size, and this was specially hollowed out so one could look out and have a wide angle view of the outside, but nobody would know what's going on inside. And this was for the Janana area in Amer Fort. A more common thing, which is for the special areas, the royal areas, they were with the jalis, and then the jali also controlled. They let the wind in, but they had larger openings for view. Then this is an example from old Delhi where they separated these the openings into 2 parts. One is at the top of the room, and another one at the top, at the bottom. And they never had any question of view through this, so view was not important. In the other one, the view was important. Here it was only the fact that you have opening the two different levels which enabled ventilation to take place, again from cool air coming in and warm air going out. So this is from Ahmedabad, again the jali being used as a means of controlling the temperature outside. This is what the window from Amer Fort, although it is actually from Agra. And then finally, many of our traditional buildings were designed in such a way that they would be perfectly horrible places to live in if we tried to live in them as they are today. This is Panch Mahal from Fatehpur Sikri. All it has are actually just colonnades around it. And these colonnades, and you see in many of our old buildings, Agra, as well as in Delhi, that these places were not very comfortable spaces, but they always had things, that skins that they would hang here, and the skins could be very fine screens or they could be thick curtains, and they were according to what they wished to have as a, whether they wanted to have less insulation or more insulation, these screens could be rolled up. And this is how they managed to control the indoor environment, and these places became comfortable. Again, the issue of microclimate modification by controlling not just the building but the spaces around it. So here was a case where they put in a large pond around this Panch Mahal, and that humidified the place in a climate which was very dry. The courtyard effect is what was used in Old Delhi as well as in Jaisalmer, and the courtyard effect was, I have already said about this, so I will just skip this. The courtyard at night was, in the daytime it was the sun which drove the ventilation, but at night it was the night sky which cooled down the roof, and the roof was cooled down, and then it cooled the air next to it, and eventually the air was drained down into the courtyards and through that into the buildings, and this is how the buildings were cooled at night. The roofs were also special places which were the coolest space in the house, and the way people used these houses was that they would sleep in the summer, they would be sleeping at the rooftop, and in winter the daytime would be spent on the roof. So this is how flexible their way of use of space was. We have not talked about additional methods that people used here, but in Jodhpur and in Jaisalmer we found that they also had shafts, and sometimes these shafts, ventilation shafts which are vertical, they also had wind catchers on them. The wind catchers of Sindh are very famous, but they also use these in Jodhpur as well as in Jaisalmer. Here is an example from Iran, where the wind towers are very tall and they drove clean air. It was not dusty air. The air was brought down through a tunnel, and they had some amount of water spray within this tunnel. Here there will be a fountain, and the air went out through this. This is heated up, and the air went out through this, and that's how the circulation system was set up. So the use of water was important. It could not be used without control because they didn't have much water. And then this is an example from Amer Fort. This is what you see around, this is a water cascade, and they have a perforated jali here. You can see some light through this. The air comes through this, and it through over this water as well. And they have all the rainwater harvesting systems that Anupam Mishra was talking about in this area, and that's how this water was brought to the top of the hill and taken into these areas, and then through this, and that is kind of cooled down the special areas in this fort. This is also part of the rainwater harvesting system, but these were also social spaces. If the if the houses were not comfortable and you wanted actually Mishra had already shown this as a meeting place where you could have a conference. So I come now to, what has changed for us. We have actually a new set of requirements for buildings, and one of them is transparency and privacy. Transparency and privacy actually are contradicting things. Facebook epitomizes this very clearly. People want to be seen only by they want to be seen on Facebook, but they don't want others who they don't want to see them on Facebook. So there are problems of privacy. We want our buildings to be 24/7 operational. Again, it's like the internet. We don't want to do anything ourselves. We want everything to be automated, and we want everything to be done at 4G speed. People talked about the impersonal spaces here already. I will not do that. I will not talk about it. But we have actually got a new set of comfort standards. This is the biggest problem that we face today, that we have changed. It is not the building so much, but we have changed. We are actually demanding that we must have air conditioning, and without that a building is not actually complete. And we want light in our buildings. Now this is something that all the old buildings suffer from. There is never enough light in the old buildings for work to be carried out, and we want work to be done in these buildings. So we have a different kind of thermal problem here. Then the problem of international appearance and world quality, which others have talked about. These have also affected by how we use the buildings. Now I have few contemporary examples of how we have tried to respond to this. This is a small building, a guest house in Gurgaon for the Solar Energy Center, which was an earth sheltered building, trying to use thermal mass in this, natural ventilation through this, and building into the landscape in this case. Here is a building, an experimental building. Was done in Jodhpur, a hostel, and this hostel was, it had a cooling tower from the top, and one could draw air through this cooling tower, and that air went through all the rooms, and there were special vents here at the top of this building, and there was a cooling system which was with water screens here that was used in this particular building. The courtyard is something that this is one of the contemporary courtyards that we have built. The courtyard actually has lost its meaning because we no longer accept the fact that the courtyard is part of the living space. You will see this, but you will have a door in between the two. People don't want that kind of free space, but this was an example where this did happen, where the living room is where the photographer is, and the courtyard is very much connected with this, and it is open to the sky. This is an office building with the courtyard, and it was done, this is in Gurgaon, it was done specially for somebody who didn't really want air conditioning. So this had to have cooling, but it didn't have to have air conditioning as such. It was done with evaporative cooling, and actually giving this building the appearance of a non-air conditioned building which is just cooled by this courtyard. Eventually we discovered that people were not very happy with air cooling, and that it affected certain, this is for the American Institute, which had some archives in this as well. And so eventually this was air conditioned, but only the spaces around the building were air conditioned, and the passages and common spaces were all left as they were, so that the building gives the feel, and people are not very demanding on how much air conditioning they can have. The idea of the jali was used in this particular office building. On the left is what it looks like from the outside in the daytime, and inside you can see that these jalis actually disappear and you can look out through them. and at night the jalis disappear and one can look into this building. Then there is, this is I think the last example, or maybe there is one more, of a set of buildings that we did for the NIIT. Now this is in the desert, and one wanted to have a low energy cooling system, and so air was the thermal mass of the ground itself was used as a method of cooling. Air was drawn through the ground. There on the right is this air intake tower. Air is drawn through that into a tunnel which is about 60 meters long, and then this air cools down by a few degrees, 6 degrees maybe, and then it is taken further into through an air handling unit, cooled down by evaporation in the summer, dry summer months, and then it is supplied to the rest of the building and it goes out through the top. This works well in the summer months, but it does have some problems of humidity control in the the humid part of the year, and that is where the air handling unit has a dehumidification system, which is normal air conditioning. So for the time of the year when this is requiring when we have a humid condition outside, this building is not very satisfactory. This is a system which is different from the building that you have here in IIT. I think it's called the Environmental Center or something like that. Yeah. They also have a tunnel, but the tunnel is not really supplying air to the city. It's just a small amount of air which is being replaced. The problem with this or the effect of this kind of system here was that there is dust control which is required in Neemrana, and it is not just a question of cooling the building, it is also a question of dust control. So these buildings were supplied with 100% fresh air all the time, and that was there was an air washer in the air handling unit, so the dust was never there. It is actually very good method of dust control in the buildings, and they don't have to clean them as much, but there is a humidity problem here. This is part of that open space between the buildings of the academic buildings. Because of this humidity problem that they had in the first set of buildings, first set of hostels, actually the academic buildings still work, but the hostels are 24/7, and it was the earth air tunnels could not really handle that. So the second lot of building, which are hostels, were built with evaporative cooling, central evaporative cooling, and that works. And since there was no dehumidification system, this was not something which was expected out of this. This is one of our own buildings which has got a downdraft evaporative cooling system, and the idea here is that this is a factory workshop and so on. So air is drawn through the top, and there is a wet dehumidification of the air, and by the arrangement of shafts one is able to make the air move through this building by itself without having a fan. The fan power used in the NIIT building was enormous actually, and that takes away from some of the energy savings. In this case, there is no energy used for the fan. Thank you.